Hello and welcome back to Get Great at Maths. I'm here to help you pass your maths exam, so hit that like and subscribe button. We're going to look at keywords, key formulas and how to gain top marks. So let's get ready to get great at maths. This is a question on upper bounds and this is linked into the rest of question 9. So please see my previous videos on question 9A and 9 part B part 1 to see how to do those parts, which will help you answer to this part here in part 3. Now on part 3 we're going to identify the keywords in the question. You've already seen these from my previous videos that the width is 60, is to the nearest centimetre. We have got 6 of these cupboards and the wall is 363 centimetres to the nearest centimetre. This time in part 2 we've got to find the upper bound of the space remaining if 6 cupboards do fit along the wall. So this is the difference this time, is that the cupboards are now going to fit along the wall. What is the upper bound of the remaining space? That's what we've got to find. And this is worth 3 marks. Now the key parts of this question are that the upper bound is the value plus half the nearest value. The lower bound is the value take away half the nearest value. The minimum length is 2 lower bounds added together. And the maximum difference between the length is the upper bound take away the lower bound. And we're going to need all these formulas in order to be able to answer this question. If you're ready to answer the question and you've done my previous videos, you can pause the video now and then have a go. If you haven't looked back at the videos, you can use the information that I'm just providing now, which we did in 9A part 1 and B part 1. So we've been given already to the nearest centimetre is 1 centimetre. And then half of that is 0.5, so we already know the lower bound of the cupboard, the upper bound of the cupboard, the error interval for the wall, so this is the lower bound of the wall and this is the upper bound of the wall, and you're going to be needing to use all this fact in order to answer this question to find the upper bound of the space remaining. Press pause, have a go at the answer, press play when you're ready to hear the answer. Well done guys. Hopefully you've got a great answer. Give me a big thumbs up and a smiley face in the comment box below if you've got an answer, or write any comments if you're unsure on how to do anything still, or you want a video on something particular. Just let me know and I will do a video for you. So on this question here, this is worth 3 marks and we've got to work out the upper bound of the spacing remaining. So this time I've got a wall and the 6 cupboards are going to fit along the wall. So to make sure that they definitely fit along the wall, we're going to take the maximum length of the wall. So here is the length of my wall. It was 363. 362.5 was the lower bound. 363.5 was the upper bound. So we want the maximum length of the wall to make sure that these cupboards are going to fit in here. Previously, we looked at the upper bound of the cupboard. But this time I want to know the lower bound of the cupboard, this value here, because I want to make sure that the cupboards are definitely going to fit in. So I'm going to use the 59.5 to make sure that these cupboards actually fit in. So the question wants to know the space remaining. So this distance over here on the right hand side is the space remaining. So I need the maximum length of the wall, the minimum length of the cupboard, and then this distance here on the right hand side is the space remaining, which is what we've got to find. And the biggest value of that space remaining is the upper bound. That's why it says upper bound, because we want to find the biggest space. So in order to do this, we need to know the total length of the minimum cupboards. So if I do my 59.5 times 6, which is the distance from this end to this end of the cupboards, which gives me 357. Now to work out this space remaining, I need to do the maximum length of the wall, take away the lower bound of the cupboards, which will give me 363.5, take away 375, which is worth 1 mark. So we've got 2 marks so far out of 3. The third mark comes from working out the answer to this, which is 6.5 centimetres, and this is worth 1 mark. You're allowed a calculator, so you can literally just type those values in the calculator to get your answer. This is where the 3 marks were awarded. This does rely on your answers to 9 part A and 9B part 1. So please make sure you know how to do those previous parts, because if you made a mistake earlier, then you're going to struggle to do this last section here. Don't worry if you couldn't do the first parts, you could still get a method mark on this question because in the mark scheme you'll be allowed to use your answers if you made a mistake anyway. So don't worry if you got the first bits wrong, you could still get method marks as you go along. We're going to talk about the mark scheme in a minute and show you what was actually awarded by the examiner. So here's the mark scheme. You're told you're awarded 3 marks. M2 means 2 method marks. This is for doing the 363.5 take away 6 times your lower bound. As I said, the word there here is really important. So if you made a mistake earlier for your lower bound, you'll still get a method mark. And M1, the next method mark, is for just either working out the maximum length of the wall or 6 times your lower bound, so your bare lower bound of the cupboards. So make sure that you show you're working out in order to get the maximum method marks, because if you just wrote down answers without showing where they're coming, we can't award the mark for this word here, there, if you haven't shown where the numbers are coming from. If you'd like a video on anything in particular, please let me know and comment below. Remember to like and subscribe so we can get great at maths all together. If you've enjoyed this video, please don't forget to like and subscribe. Comment below to let me know what you would like to see in my next video. See you next time!